cloud computing and its limitations to support low latency and round trip time RTT. I am Dr. Rajiv Mishra, working as professor at the Department of Computer Science Engineering, Indian Institute of Technology, Patna. Contents. On this completion of the session, you will get to know the following details. That is, you will be introduced to the understanding of today's cloud scenario. Then we will talk about different objectives of cloud, then current limitations of traditional cloud, then why there is a need of edge computing we are going to reveal in this part of the lecture. Let us start about talking or understanding the current state of today's cloud. So, current state of today's cloud, you can understand it as highly centralized set of resources. What do you mean by this? Is that the VMs are virtual machines which is being offered by the cloud is often being provided from the remote data centers, which comprises of several servers. So, the servers are at the remote location. Often the centralized set of servers are at one place, and that is called the data center, and this comprises of highly centralized set of resources such as the compute, the storage, and so on. Now, this particular way of using the compute with the help of virtual machines was emphasized earlier about the cloud usage. Now, this particular way is now moving away from virtual machines to the today's world, that is called container. So, applications are now preferring container rather than virtual machines due to the modern way of development of the software. Another important current state of cloud is that storage is now complemented with content delivery networks. So, what do you mean by content delivery network is that storage, that means when the storage is used from the cloud as a service, then it is complemented with the content delivery network, so that the accessing or retrieval system becomes quite fast, because it is complemented by content delivery networks. Another thing which is very important to understand in today's cloud is that network is often programmable. So, the entire network stack is now programmable. What do you mean by this is that it can be used depending upon the application, how that application is going to use the network, that is called intent, can be given to the network, and network will serve in that way, that is called programmable, that we will see in today's cloud. The web and software as a service is another important way of development. Like you might have seen that software as a service is the way by which you can, or many applications can run in this particular way as a service from the cloud providers. So, today's cloud is now moving towards providing the service such as software as a service, and often through the web. Then finally, infrastructure as a service was quite prevalent, and still it is being used because of the efficiency or performance purposes of building the applications using infrastructure as a service. Another important state of today's cloud is that it provides you high availability of the cloud, and this is continuously improving from the previous generations of the cloud. Let us understand this in the following manner. So, the current, what do you mean by the highly centralized set of resources in today's cloud, and how this set of resources are to be brought to the client or the customers from the cloud providers. So, that uses the client server architecture. Let us understand the entire scenario, and this will explain you about what do you mean by the highly centralized set of resources in today's cloud. So, cloud computing started as all about the virtual machines they were running in the remote data centers. So, take this kind of example here. So, this is the cloud data center, let us say. And this cloud data center often provides the virtual machines to the clients. Now, to access this particular virtual machine is meaning to say that this particular data center or a highly centralized set of resources is being provided as a service to the clients or the customers. So, this particular model, that customer becomes the client and the data center often becomes the server in providing this highly centralized set of resources to the client. This particular model is called a client server architecture. So, the cloud computing is or the highly centralized set of resources is being provided in the form of client server architecture that we have explained through this particular figure. Now, let us start understanding that the cloud computing is all about the virtual machines in this particular scenario that were running in a remote data center, or the storage also that we have already seen in this particular way. This is the data center, and inside this it provides the virtual machines, and this virtual machine is mimics the physical machine. When you say physical machine, it means that virtual machine has the CPU, storage, operating system, storage and everything, and that is being accessible by the client using client server architecture. Now, this highly centralized architecture resembles a specific paradigm of computing that is called client server computing. For example, the remote data center here becomes the server, and this particular server is often exposed by the Amazon, Microsoft, Google, IBM and many other vendors. Often is the server in client server architecture, and the machines from which you are connecting to it, that is the client machines, they are consuming the cloud resources, becomes the client. So, here in this particular slide we have explained you what we mean by the highly centralized set of resources often exposed by the companies like Amazon, AWS, Microsoft Azure, Google Compute Engine by Google and IBM and many others as the servers, and the machines from which the clients or the customers are connecting and consuming these set of resources, they become the client in the client server architecture of a highly centralized set of resources. Now, what do you mean by saying that compute is going beyond virtual machines? Like in the previous slide, we have seen that the highly centralized set of resources in the form of CPU, memory and so on is available from the data center of the cloud provider in the form of virtual machines client can access using client server architecture. Now, this virtual machines was introduced in the first generation cloud. Now, this particular using virtual machines providing the resources or accessing the highly centralized set of resources of the cloud is now shifting in another way, that is called the containers. So, the compute is going beyond the virtual machines, and that you can see that where you can programmatically launch a virtual machine, or you could SSH it to take control of the virtual machine, install the software. That means, if you are using the virtual machines in this way. Now, there is a dramatic shift in compute where virtual machines are slowly getting replaced by the containers. That is what I have explained, that in these virtual machines are being replaced by the containers. Now, containers are being provided by the cloud providers to the clients who are writing new kind of applications. Using container are more convenient. That is why the technology is changing from virtual machines to the container, and that's how this particular current state of today's cloud is having the compute going beyond the virtual machines towards the container. Now, therefore, today more and more workloads are moving towards container and not the virtual machines. Now, when we say that the storage is complemented by content delivery networks, meaning to say that this is an important trend that almost all the public cloud are giving the storage offering. Now, object storage is complemented by content delivery network today. So, meaning to say that whenever you put an object in a bucket or in a container in a public cloud storage, and you can click a checkbox to basically replicate and cache the data across multiple edge location, but this edge is not the edge we are talking about. This is called content delivery network. When it caches frequently, it caches the frequently accessed content in a setup of POP or the edge locations. So, meaning to say that, let us summarize this. So, when we say that the storage is complemented by content delivery network, meaning to say that the cloud, public cloud which are offering the storage as a service. So, that means the object storage now is being provided or is complemented by content delivery network. What do you mean by that? Is that when you put an object in a bucket or in a container of a public cloud storage, then what you will do that if you are using this content delivery network for retrieval, then it will replicate that object which is being stored at several places, and they are called caching the data across multiple locations, and they are called edge locations. So, this is quite different than the edge computing, that is what it says, but replicating that object storage at multiple locations, the content delivery is cached and frequently accessed content is POP at different locations. They are called edge locations, and therefore, the retrieval becomes faster. Using the caching at the edge locations. Now, when we say that the network is network is programmable. So, let us understand this notion. Finally, the network has become extremely programmable today. If you look at the hybrid cloud, multi-cloud, how the network traffic is getting routed and how the load balancers, firewalls are working together to realize this client server architecture in a hybrid cloud, multi-cloud scenarios. So, networking becomes important, but the network has to be now intent based on what application wants. and a variety of network components are therefore configured, and it is accessible through APIs and programmability. So, the same capabilities of software defined network is enabling hybrid scenarios, particularly when we look at the combination of software defined network with some of the emerging network technologies. Now, these mesh, they are opening up additional avenues. Some of the very recent trends like Google Anthos, IBM Cloud Private, and some other container based hybrid cloud platforms are heavily relying on programmable network stack, a combination of. So, programmable network stack is often a combination of software defined network and a service mesh. So, this is the current state of the cloud, and these trends represents how the cloud is currently being consumed and how it is being delivered to the customer, but the cloud is going through a huge transformation because of these kind of technologies called software defined networks and the service mesh. Now, let us trace back that multiple waves of innovation is happening in the cloud. So, today's cloud is changing. Why? So, it is because of this multiple waves of innovation in the cloud, and we are called as a IoT pass. So, let us understand this concept of multiple waves of innovation in the cloud. Initially, the cloud was all about compute, storage and network resources globally available in the form of highly centralized set of resources. Because the cloud made compute and storage extremely cheap and affordable, a lot of industrial customers and enterprises, they start connecting the devices to the cloud. So, therefore, data that was not perished or aggregated or acquired is now streamed to the cloud, because it is extremely cheap to store the data in the cloud. So, lots of companies and lots of industrial environment started to take advantage of the cloud by streaming the data coming from the variety of sensors and the devices. Also, use the cheaper compute power to process those data streams and make sense out of the raw data generated. These sensors and devices that were the next big shift in the cloud, and this was that was the next big shift. So, let us see this entire discussion with the help of. So, let us say that these are the sensors, and these sensors, they are deployed, let us say that in a smart city environment. So many sensors are sending the data, and this particular data is now pushed to the cloud. And lot of sensors are sending the data. Why? Because cloud provides a cheap way to store the data in the cloud. Therefore, the companies who are using the sensors or an IoT sensors often use the cloud. So, cloud is growing because of this particular IoT based applications. So, lots of companies and lots of industrial environment, they are started taking the advantage of the cloud by streaming the data coming out from. So, this is called streaming the data coming out of these particular sensors. Now, what the cloud will do out of this particular data? Not only it provides the cheaper way of storing, but also when the data comes to the cloud, so it now has the cheap computing power to process these streams of data, and this is called data analysis, which will make the sense out of this particular data coming out from sensors, and this is called an IoT pass. So, this IoT pass led to the growth and this is called one such wave of innovation in the cloud, and this is called IoT pass. Now, let us see what are the challenges are there for an IoT pass. So, if you look at different service cloud providers which provides this kind of innovation of an IoT pass, it is called Azure IoT. Similarly, Google also joins this IoT pass innovation in the cloud, and that is called Google Cloud IoT and AWS IoT. So, these all have essential the mechanism or a platform to connect the devices and store the data and process it in the cloud. So, that is what we have seen is called an IoT pass. So, all those cloud service providers they have joined this innovation wave of innovation, but it was not sufficient or it was not enough to address a lot of scenarios while the cloud enabled capabilities like big data and the IoT. Now, lots of customers were not ready to move the data to the cloud. That was one challenge. So, we are talking about the challenges in an IoT pass. So, they were not ready to move the data to the cloud. That was one of the challenges. This is the first challenge. The second one is that round trip time from device to the cloud and back to the device was too long and was increasing the latency in a lot of mission critical industrial applications. Take this example that if let us say you have the industrial sensors or an IoT sensors deployed in an let us say that industrial environment, industry IoT, let us say that. So, all of them would be sending the data or streaming the data to the cloud. So, they are sending the data and often this cloud will do the computing and returns the data back. This entire sending the data, doing the computation or analysis in the cloud and returning back the result is called round trip time. It requires the delay in sending the data to the cloud, doing the computation and getting the results back. So, this total time is called round trip time, and it becomes quite substantial for IoT applications, and this particular substantial delay or latency is not acceptable in some of the mission critical applications. So, sending the data to the cloud and waiting for the cloud to process it and send the result back was not feasible. So, there had to be a mechanism where data could be processed locally. So, without sending to the cloud, how the data can be processed. So, whatever was processing earlier in the cloud, how that all can be done without sending to the cloud. This entire processing can be done close by locations, not to the cloud. That is one such requirement. So, how the IoT? So, that is how this IoT pass led to the edge computing, and in today's every mainstream enterprise IoT platform has a complementary edge offering and associated edge offering, and more recently has been a lot of focus on the artificial intelligence. So, if you understand that the data which these sensors are sending to the cloud, normally the cloud is using AI or artificial intelligence on this particular data and then sending the results of an AI back to the sensors or actuator to the industrial scenario. So, if you want to avoid sending the data to the cloud, that all the functionality has to be mimicked to a close by, and this is called an edge computing. Now, there is a choice whether to go for the cloud computing or the edge computing. If the latency sensitive application where this round trip time becomes very important to reduce, and they are called latency sensitive application, there comes the edge computing. Now, why this edge computing is because earlier the cloud was used for performing the artificial AI and ML. That is why the IoTs or the data is being sent to the cloud to perform the AI and machine learning on the data. So, today's cloud has become the logical destination for training and running the AI model and machine learning model. That is why this particular cloud is performing AI and ML. So, data, once the data is available, then it can use the data and perform the AI and ML, because the accelerators like GPU, FPGAs have become quite cheaper and powerful to train very complex and sophisticated machine learning and AI models. So, there is another development that now instead of sending it to the cloud, can instead use accelerators called GPUs and FPGAs, and there you can perform the sophisticated AI and machine learning models like cloud. So, that technology has emerged and which has challenged for doing machine learning or AI at the cloud. So, in most of the scenarios, a model that is restrained in the cloud is going to run in an offline environment, like with the advent of GPUs. This thing is a possibility that instead of cloud, if you have the GPU, you could also perform AI and ML model training and inferencing without depending upon the cloud. For example, if you have a trained AI model that you could identify the make and model of a car and automatically charge the toll fee for the vehicle that it passes through the toll gate. Now, since the toll gates are on the highway and freeway with a very little connectivity, almost no network connectivity, you need to do this kind of inferencing or a model training in an offline mode. So, this particular another scenario where connectivity is quite little or intermittent connectivity is there, then also the cloud cannot be used for performing AI and ML. In that case, the edge computing became the boundary for running these cloud trained AI models, but running it in offline mode with the edge. So, that is how we are basically looking for the evolution of the cloud and the waves of innovation. So, this wave of innovation is bringing the AI and machine learning to be performed away from the cloud at the source itself, that is called the edge computing. So, this wave of innovation that is led from AI and ML not to be done at the cloud due to the latency sensitivity, it can be performed at the source locations. So, that round trip time can be avoided. So, the cloud are distributed or rather decentralized platform for aggregating, storing and processing data with high performance IoT devices to the cloud with an IoT data at the edge made the cloud decentralized by bringing compute closer to the data source, and now it is AI that is actually driving the next wave, where cloud is becoming a de facto standard for training the model and edge becoming the de facto standard for running the model. So, one is called training, the other is called inferencing. So, therefore, machine learning, if you see this wave of innovation, has been using the edge. This is called the edge and this is called the cloud. So, the cloud is used for the training the AI or a machine learning model and the models, and then this edge which is close to the sensors or source, this edge is used for inferencing. So, training plus inferencing was nothing but earlier performed at the cloud. Now, both are decentralized with the help of the edge computing. So, let us trace back the limitations of current cloud system. So, AI use cases need real time responses from the device they are monitoring. Cloud based inference cannot provide this real time response due to the inherent issues with the latency. If the edge devices have connectivity issues and no internet connectivity, then it cannot perform. Sufficient bandwidth is required to transfer the relevant amount of data in a proper time frame. So, it can be an issue. So, these are some of the limitations of the current cloud computing scenarios. Therefore, we are summarizing all the innovations or multiple waves of innovations in one specific slides, that we are moving from cloud to the, due to the IoT, it is moving from cloud to the edge computing to perform machine learning. So, here you can see what we have so far discussed is the current state of the cloud means that it is a highly centralized set of resources, resembles client server computing. Compute is going beyond virtual machines. Storage is complemented by content delivery network. Network stack is programmable. So, this becomes the current state of the cloud. So, that was the current state of the cloud. Now, because of the IoT requirements, so all the data coming out from the sensors in an Internet of Things and devices, earlier this cloud has grown and was supporting this IoT applications by way of providing a cheap storage and cheap compute. Now, but it has the disadvantage of latency and the bandwidth or the connectivity. These are some of the limitations of an IoT pass in the cloud computing using the cloud. So, therefore, it was understood that why the data is sent to the cloud to perform the AI and machine learning. So, AI and machine learning rise are now being exploited to understand how the machine learning and AI is being used is having two different phases. One is called training and the other is called inferencing. Everything was done earlier in the current state of the cloud in an IoT pass. Now, because of this issues of latency, bandwidth and connectivity, three important factors are now required to build a new kind of applications. Therefore, it requires another way of performing those AI and machine learning. The training can be done at the cloud and inferencing can be done at the edge. So, new kind of edge, that means the intelligence can be offloaded from cloud to the IoT devices, and that is called the edge computing. So, this example of a edge computing use case can be seen over here, that consider an industrial IoT data. So, industrial IoT let us say that the sensors which are deployed at a particular site, let us say that oil exploration site has a lot of sensors deployed over there. These sensors often generate huge amount of data, and they are generated out of different sensors. Oil and gas industry, if you take what sensors they are using, is they are using temperature sensor, pressure sensor, velocity, and many more sensors is being often used. Now, these sensors are keep on sending the data constantly to the cloud. The size of such data ranges from terabyte to the petabyte. So, you can see that streaming of this amount of data per second comes under the big data generation, and that is only be supported by the cloud. So, it is now another problem is that it is practical to send all the data of a sensors or IoT sensors to the cloud environment for processing due to the number of factors. First is that there is a high cost of connectivity of all the sensors to the cloud. Another thing is the cost of bandwidth latency involved. Moving all the data to the cloud requires huge amount of time delay, and the security risk also sometimes that vital sensor data is now posed by the security threats. All these things has led to the edge computing use case. So, edge computing will resolve all that in the sense that data need not to send to the cloud, all the data need not to be sent to the cloud, only the data. So, all the this one inferencing can be done at the edge. So, it will avoid sending the data to the cloud. So, it is therefore, edge computing enables that not only dependent upon the bandwidth, not dependent upon the connectivity. So, the latency, all these things have to be removed, and also important concept is that security threat is also reduced in this way of edge computing being involved. So, what do you mean by the edge computing? Let us summarize understanding about the edge computing. So, edge computing makes the cloud truly distributed. That means, earlier cloud was highly centralized, but now with the edge computing it will make the cloud truly distributed. Now, it will move the core cloud services closer to the origin of the data using the concepts of the edge computing. Now, this edge computing mimics the public cloud platform capabilities, that is, it can also deliver the storage, it can also deliver compute and network services, not centrally, but highly locally by the edge computing. Edge computing also reduces the delay by avoiding the round trip time in sending the data and getting the results back from the cloud. It also edge computing also brings in data sovereignty by keeping the data where it actually belongs. That means, it is processing at the source itself. Source means in that industrial environment itself, and thereby saving on the cloud and the bandwidth usages. Now, let us understand more detail about the functionalities which will be there in the today's edge computing. So, data ingestion and machine to machine brokers, object storage, function as a service, containers, distributed computing, NoSQL time series database, stream processing, machine learning models. That means, all the functionalities whatever cloud computing earlier offers has to be mimicked by the decentralized edge computing. So, in the edge computing understanding, so we have to see that the edge computing operates on the underlying principles of Docker container, Kubernetes, MQTT, Kafka, time and clock synchronization, key values stored at the edge, recent advances in the machine learning inferencing at the edge for the use case such as predictive maintenance, image classifier, self-driving car for IoT such as Internet of Things or Industry 4.0 requires understanding of the concepts and bringing the edge computing or cloud-like functionalities close to the devices, and that is called an edge computing. Now, cloud data centers. What is the current demand? In the next decade, you will see that that skyrocketing growth of IP connected mobile machine to machine devices will handle significant IP traffic, and tomorrow's customer will demand faster Wi-Fi application delivery from online providers. Also, some machine to machine devices such as autonomous vehicles will require real time communication with local processing resources to guarantee safety. Today's IP networks cannot handle high speed transmission that tomorrow's connected devices will require. In a traditional IP architecture, data must travel hundreds of miles over the network between the end users, devices and the cloud resources. This results in the latency and slow delivery of the time sensitive data. This you can see that how you can increase the speed of the network delivery towards the cloud data center, from that is in the client and server mode of communication, how the networking has to be increased. So, you can see that the current state of the cloud uses the 4G, that is only a few large centralized data center it assumes, but they are more than 500 miles away. So, the applications, let us say self driving car, where the latency is more than 80 milliseconds in this case, is not acceptable, or it will not be able to drive the self driving car by getting so much of delay. So, vehicle moved over the 4 feet by the time it has received the response due to the large distance from. So, this kind of latency in the current 4G and the cloud data center becomes a bottleneck, and therefore, a new upcoming technology 5G, where the data center becomes micro data centers, that is data centers are very often not centralized cloud data center, but they are micro data center very close by to the cellular tower, need not have to send the data to a 500 miles away to a centralized cloud data center, but they have to send it to the micro data center which is less than 5 miles away. So, the latency is substantially reduced. Therefore, the new kind of application like self driving car is now experiencing a latency of less than 5 milliseconds, and therefore, you can now think of building a self driving car using this kind of model, where you are now having a decentralized data center, they are called micro data centers, which are there with the every cell tower. Therefore, we call it as edge data centers. So, we are moving away from cloud data center to the edge data center is a solution. So, solution to reducing the latency lies in the edge computing. So, by establishing the IT deployments for the cloud based services in the edge data center in the localized areas. So, often effectively bring IT resources closer to the end users and devices. So, this helps us high delivery of applications and data. So, edge data centers are typically located on the edge of the network. So, you can see that this is the devices, and close by this is called the edge. So, the data centers are now often micro data centers, and they are called edge data center, which are very close by to the cellular towers in 5G, and where the cloud is having called cloud data center. So, again I am repeating that edge data centers are typically located at the edge of the network. This is called the edge of the network, with the connections back to the centralized core. Now, instead of bringing, so what we are now introducing here is called edge data center, that sits between the devices and the cloud data center. Now, instead of bringing the users and the devices to the data center, like earlier this particular devices were earlier brought to the cloud data center. So, instead of doing that, we bring the power of the data center to the users and the devices using this edge data center. So, establishing the edge data centers at the edge is making this kind of possibility, bringing all the resources very close by to the devices. So, edge computing relies on a distributed data center architecture, in which the IT cloud servers houses in the edge data center and deployed outer edge of the network by bringing IT resources closer to the end users and the devices they serve. Now, this you can achieve high speed, low latency processing of the applications and the data. So, let us see about the edge data center as a solution in this particular scenario, which requires the low latency applications. So, here you can see that now you have in the lowest layer, you have the Internet of Things, or let us say IoT gateway. All of them are generating the data, and the data is now often intercepted or being accessed very close by to the device, or they are called the edge, and they are called micro data centers with a very little latency. They are called low or ultra latency. With a very low latency, they are being processed. Then comes a higher level than the micro data center. They are called cloudlets. So, cloudlets also has a little lower latency compared to the cloud data center. And then finally, it becomes a core. So, core means the cloud data center handles the core here in this case. So, core means that it can be supported or with the high latency, it can be supported, but it is supporting with a high latency, it is supporting high capacity fiber, long term data analysis, archiving and so on. So, you can see this kind of scenario is there, that there is a edge computing which is being provided with the help of micro data centers, then near the edge called cloudlets, again same micro data centers are providing in the edge computing, and away from it is the cloud data center. So, cloud data center, edge data center, that is the edge and cloud works together in conjunction. So, why move the cloud services to the edge? There are four main benefits of moving the data center to the edge. First is called latency, second is bandwidth, third is operating cost, fourth is security. Let us understand each one by one. Latency means that what is the benefit of the first benefit is the latency, that if you move the data center to the edge. So, edge data center it is called, it will facilitate the low latency, meaning much faster response times, locating edge and storage functions closer to the end user reduces the physical distance that the data packets needs to traverse, as well as the number of network hops involved also are reduced. So, which lowers the probability of hitting the transmission path where the data is impaired. So, latency is one of the important benefit of moving the cloud data center to the edge, that is called edge data center, brings in the lower latency. It will facilitate lower latency and faster response time. Second important benefit is about the bandwidth. So, edge data center process data locally, reducing the volume of data traffic flowing to and from the central servers. So, in turn it saves a lot of bandwidth and improves the overall network performance. So, you can see that so much of traffic which earlier in an IoT path was moving to the cloud is now saved, bandwidth also is reduced. Here if you move the cloud service to the edge. Third important benefit moving the cloud service to the edge is called operating cost, because edge data center reduce the volume of traffic flowing to and from the central servers. They inherently reduce the cost of data transmission and routing, which is important for high bandwidth applications. So, more specifically the edge data center lessen the number of necessity high cost circuit interconnection hubs, leading back to the regional or the cloud data center by moving compute storage closer to the users. Thereby, you can see that can effectively reduce the operating cost. Fourth important thing is the security. Now, edge data center moving the cloud data center to the edge called edge data center enhance the security by reducing the amount of sensitive data transmitted. So, second is limiting the amount of data stored in any individual locations given their decentralized architecture, decreasing the border network vulnerabilities, because breaches can be the ring fenced to the portion of the network that they compromise. So, let us see the edge data center and take this kind of introduction. So, major benefits of edge data center is the quick delivery of services with minimal latency. So, thanks of using the edge caching. So, latency may be a big issue for the organization that have to work with Internet of Things, big data, cloud streaming. So, therefore, edge data center is the solution. So, edge data center can be used to provide high performance with the low latency to the end users, making for a better user experience. Typical edge data center will connect to a larger centralized data center or a multiple other data centers. In this example, it is shown that this particular cloud data center is now the services of a cloud data center is now bringing quite close to the edge data centers. So, data is processed close to the end users as possible, while less integral or a time centric data can be sent to the central data center for processing. This allows the organization to reduce the latency. So, take this example that if let us say you provide the services in the base station with the help of edge data center. So, latency is in the range of 1 to 5 milliseconds, that is what is shown over here. So, that means in this base station the edge data centers are being providing the latency 1 to 5 milliseconds. If it is the regional data center, then it will add the latency to a 30 milliseconds. So, if it is a regional data center, means that several such base stations are connected to one data center called regional data center, then the latency becomes much higher, 10 times more, and that is called 30 milliseconds. And if let us say that if you are or if your application is directly accessing the cloud data center, then the latency is in the range of much more, that is called 50 to 100 milliseconds. It is quite substantial latency compared to 1 milliseconds. So, you can see that this way, that is edge computing provides, that is the computing and storage makes closer, becomes reaches closer to the end user, and therefore, latency is reduced. Many new applications are now possible with the edge data center. So, let us conclude. So, what we have covered in today's discussion is current state of today's cloud. We have understood all the cloud scenarios to understand what do you mean by the current cloud scenario. We have also covered the objectives of the cloud. The current limitation of the traditional cloud we have brought very carefully here in this particular discussion, and then we have also introduced you about the need of edge computing, which is a new way of introducing the latency sensitive application. That was the title of this particular lecture. We have also introduced you that to perform this edge computing, you require the deployment of the new kind of data center called edge data centers. We have explained that also. Thank you.